Hey everyone! So in this video I'd like to talk about written homework 4, and I'd like to go through each problem. And so the first problem asks us to describe in words how we can graph a linear equation in the different ways we've learned so far. And so here I'm not going to write all of this down because I think this will make the video take too long, but we're given 3 different ways we've learned how to graph linear equations, and so let's just talk about them. So here, making a table. How do we graph an equation, a linear equation, by making a table? Well, linear equations, and we have some examples in problem 2. Linear equations, the equations in 2 variables, there are typically many solutions to that equation. I can plug in different values for x and figure out different values for y that make the equation true. And so, when we graph an equation, we're just drawing a picture of all of the solutions to that equation. So if we want to graph a linear equation, one way we can do it is by finding some solutions, and then plotting these solutions, and then drawing the line that goes through these different solutions. And so making a table is just a very explicit way of doing that. And so let's see that. Maybe let's do that for this example here. Let's look at y is equal to -3 over 2x plus 4. Let's find some solutions to this equation, and let's use it to graph the equation. Well, here, one nice number I can plug in is the value 0 for x. And, what would that mean y should be so that the equation is true? Well, we can just run the numbers, right? So -3 over 2 times 0 plus 4, well, that tells us that y needs to be, 0 times anything is 0, so 0 plus 4. So what we get, which is just 4. The only way this equation is true is if y is 4, if we're letting x be represent 0. So here, this is a solution to our equation. A graph is just a picture of our solutions, and so this is going to be one point on the graph of this equation. And to graph an equation by making a table, well, we just have to do this multiple times over, find many different solutions. And so, we can plug in numbers like 1, right? Y is equal to -3 over 2 times 1 plus 4, and we can try and find what y needs to be to make this equation true. And here, we've got a fraction, -3 over 2 times 1 is just -3 over 2, and adding that with 4, well, we can't really add fractions unless they have a common denominator. And here, if I've got a denominator of 2 in my left fraction, well, I need a denominator of 2 in my right fraction. Well, now notice that 4 can be rewritten as 8 divided by 2, right? 4 is really the same thing as 8 divided by 2. And so I can rewrite 4 as 8 over 2, and all of a sudden now I have fractions with the same denominator. And so to add these 2 fractions with the same denominator, I just add their numerators. So -3 plus 8, right? So actually, I might have skipped something real quick. Remember that a negative of a fraction, -a over b, this is the same as saying -a over positive b, or a over negative b. Right? So if we have a negative fraction, we can put that negative in the numerator or the denominator, not both though. And so here, I put it in the numerator, just to make things a little bit simpler. And now I can add these 2 numerators together now that the denominators are the same. And so we get -3 plus 8, that's 5 over 2. So here, y would need to be 5 over 2 if x is going to be 1. So that's another solution. Maybe not as friendly, not as clean as you'd like, but that's another solution. And so that's going to be another point on this curve. And then maybe let's do one more example. So, the reason we ended up with such a not friendly result was because, there's division by 2 here in this fraction. So whatever number I plug in for x, well, it's gonna get divided by 2. And if x isn't divisible by 2, if it's not an even number, we're gonna not end up with a nice, clean, whole number result. But if we do plug in even numbers, like 2 or 4 or 6, we do get a nice result, right? If I plug in 2, what happens? Well, we get y is equal to -3 over 2 times 2 plus 4. Well, if I multiply -3 over 2 times 2, this is like saying multiply by -3, divide by 2, And 2 divided by 2, well, that's just going to be 1. So we end up with a negative 3 times 1 plus 4. Well, this is equal to positive 1. So y is equal to 1 when x is equal to 2. Or here, let's do one more example. If I plug in 4, well, we'd just have 4 divided by 2 is 2. Then that would get multiplied by negative 3 would be negative 6. And then adding 2 on, or adding 4 on gives us, that gives us positive 2. Or sorry, not positive 2, that gives us a negative 2. Sorry, I was just sort of spaced out there. Okay, so there we have it. Those are some solutions to our equation. And these give us points to plot for our graph. So we've got the point, and here maybe I'll do this with one color because we're going to have to graph the other ones as well. I'm going to do this with green. We've got the point 0, negative, nope, we got 0, positive 4. 1, 5 over 2. Well, 5 over 2, that's 2.5, right? So that's about right here. Okay, and then 2, 1, 4, negative 2. And we can see that these points lie on a line. This is a linear equation, and then so we get something like this. Okay, I always struggle with this a little bit, doing it on a tablet, but there we go. That's a rough sketch of our line. Okay, so that's how we graph by making a table, but now how do we graph by the other ways we've learned so far? Well, we can graph by finding intercepts. Right, so the intercepts are the points. It's kind of it's a lot of the same idea as what we found or what we did just a moment ago, right? The points on our graph are solutions to our equation. Intercepts are just solutions where one variable is set equal to 0. Or maybe I'll just say set to 0. Right, so we really, in our previous example, we found one of the intercepts. We found 0, 4, where the solution where x was 0. We didn't find, or we found the y-intercept here. We didn't find the x-intercept. That's the solution where y is set equal to 0. But really, it's not so different. It's just finding solutions, just kind of special examples of solutions to our equation. And so here, let's find the intercepts of, let's use this next equation. Let's use 12x minus 8y is equal to 16. I think this will be a better example for finding intercepts for. So here 12x minus 8y is equal to 16. If we want to find the intercepts, we're going to set one variable equal to 0 and solve for the other. So I'm going to set x equal to 0 first, then minus 8 times y. We're asking for this to be equal to 16. So 12 times 0, that's 0. We've got minus 8y is thus equal to 16. If dividing both sides by negative 8, right, this is negative 8 is being multiplied to y. Dividing both sides by negative 8 gives us y is equal to negative 2 when x is 0. So we get the one solution where x is 0, y is negative 2. So I'm going to go ahead and plot that. And then another solution can be obtained by setting y equal to 0, right? So here we have 12 times x minus 8 times y, but we're trying to find an intercept here. We're setting the one variable equal to 0. And so here we're going to set y equal to 0 is equal to 16. And so we get 12 times x minus 0 is equal to 16. And this doesn't work out as nicely as the previous examples, but it's still the x-intercept. We would divide both sides by 12 to get x is equal to 16 over 12. And this can be reduced to, well, they're both divisible by 4. And so we can divide out the top and bottom quantities by this number 4 to get 4 over 3. right? And if we want to really understand what this fraction is like, we can rewrite this as 1 and 1/3. And usually I recommend working with these improper fractions. They're typically just easier all around to work with than mixed numbers. But if you really want this number to be a little bit more concrete for you to understand a little bit better, you can see this as 1 and 1/3, but when it comes to doing the mathematics with this, I would definitely recommend using 4/3. Okay, so this is telling us that when y is 0, x is 4/3. 4/3 comma 0 is a solution to our equation. So this is one solution, and this is another solution to our equation. And then of course there's infinitely many more, but these are sort of the special examples where one of the variables is 0. And so here, if I want to plot this point, 4/3, we saw that that's the same as 1 and 1/3. Okay, and that's about there, right? 1/3 of the way between 1 and 2. And here, it only takes 2 points to graph a line. We know that this is a linear equation. So here, we have 2 points to graph this line, so we can sketch this line like so. And this is a rough sketch. So, you know, it's not the most accurate line guaranteed, but here it's a rough idea of what the line, the graph of this equation looks like. And so I would definitely recommend finding a third solution to really solidify or feel confident that this is the correct picture to have in mind, and make it a little bit more accurate if you have a third solution. But yeah, so that's graphing this third equation, 12x minus 8y is equal to 16, and really this is a way for us to talk about what it looks like to graph an equation by finding the intercepts. And now the last thing we have to do is we have to explain how we can graph an equation using the slope and the y-intercept. Well, here, okay, let's do things in terms of this equation here. Y is equal to 4/3 x minus 2. So we talked about how lines, linear equations, have, well, maybe let me describe it like this. So, you know, if I think about a line, no matter which way I draw it, really, a line is really given by one point and a direction. If I have a point and I know the direction in which to extend my line, well, that really defines the line completely, right? If I have a different point, maybe a slightly different direction, well, that tells me exactly the path of this line, right? And so this is the idea of graphing with the slope and an intercept, is that, okay, we can use, you know, one special point, it doesn't matter which point actually, but why not use a special point, the y-intercept, as a sort of starting place to graph our equation, and then we can use the slope to tell us the direction in which our line is traveling, right? How many times do I have to increase my y value for every time I increase my x value to stay on the line? And so here, when we have an equation like this, y is equal to 4/3 x minus 2, this is an equation in slope-intercept form. And so equations in the form y is equal to m times x plus b. These are equations in slope-intercept form where this quantity in front of our x variable, the coefficient of our x term, this is the slope. And here this quantity that's being added on, this constant term that's being added on, is the location of our y-intercept. 0 comma b is the y-intercept. And this is only true when our y variable is isolated on the other side of the equation. If that's not the case, and we can't draw these conclusions about slope and y-intercept. So here, you know, our equation is of that form. This is the slope in slope-intercept form. And so we see the slope of 4/3. And we see the y-intercept of 0 comma negative 2. And so, you know, this should make sense as far as the y-intercept goes, because if I plug in 0 for x, well, y has to be negative 2. Okay, so here I can plot that point 0 comma negative 2, and that ends up being the same y-intercept we got for our blue equation. So that's this point right here, 0, negative 2. And we've got a slope of 4 over 3. So that tells me that if I go up 4 units and to the right 3 units, I end up with another point on the line, if we start with the point on the line. And similarly, if I were to go up 4 units again and to the right 3 units, we would again find another point on our line. Now this grid isn't all that big, so I can't really draw many more examples, but I can also go back 3 units and down 4 units to end up with another point on our line, and I think that would end up here roughly. And the graph of our equation will look something like this. So not too different from our blue line, but not the same. And so this is how we can use slope and our intercept or y-intercept to graph an equation of a line. Is there anything else I want to say about that? I'm sure there is, but I'm blanking out a little bit, so maybe I'll leave it at that. Okay, so now the last example here says to determine the value of a. So I guess we've described how we can graph a linear equation by making a table, by finding the x and y intercepts, by using slope and y-intercept, and we did so in the context of the equations given in problems 2. And we went through all of those different examples. So the last thing left to do is to determine the value of a, so to answer problem 3, so to determine the value of a so that the slope between these 2 points is 4 over 5. So let's be sure to include all the steps taken to arrive at our answer. So here we have these 2 points, 11, a, and 1, 3, and we want the slope to be 4 over 5. Well, here, how do we find the slope between 2 points? Well, if I call this my first point and this my second point, well, we kind of go through this formula that we say y2 minus y1 over x2 minus x1, where this comes from the change in y. I think I've used green in the past, so the change in y, delta y, divided by the change in x, to get from one point to the other, change in x. Well, in this case, if I'm going to start at a y value of a and go to a y value of 3, well, this difference would be 3 minus a. Right, that's our change in y, and maybe this will make more sense if we talk about our change in x. If we're going from a y value, or sorry, an x value of 11 to an x value of 1, well then here if we take 1 minus 11, that'll be our change in y, right? Here, why does that make sense? Well, this denominator is negative 10, and we can see that to go from this x value to this x value, we went down 10 units. So that difference of the ending x value minus the starting x value, that tells us our change in x. And so we can apply that same idea to our change in y. If we take our ending y value and subtract away our starting y value, we'll have our change in y. Okay, so here this is going to equal 4 over 5. Well, here, we have these two fractions. Maybe we could think a little bit more holistically. We have these two fractions that are supposed to be equal to one another. Right, so here, if I know that this fraction on the left is going to reduce to this fraction of 4 over 5, well, how can I get from negative 10 to 5? Actually, we've done things like this. We've solved equations like this in the past by cross multiplying. Right here, if we want to solve an equation like this, it's kind of like this is like a proportion. We can cross multiply. Right, I have 5 times 3 minus a is equal to 4 times negative 10. Well, this is going to give us negative 40 is equal to, and we can distribute here, 15 minus 5a. Now, how do we solve this equation further? Well, we would subtract away 15 from both sides, and this gives us a negative 55. And dividing both sides by negative 5 would give us a is equal to positive 11. And so that's what a needs to be, is it needs to be positive 11. Now let's double check that, right? If a is positive 11 here, what happens? We've got 3 minus 11 over negative 10. This gives us negative 8 over negative 10, which does reduce. If I divide the top and the bottom by negative 2, we get 4 over 5. And that's what we were asking for this slope to be 4 over 5.